Metro Manila is highly vulnerable to hydrogeologic hazard. On the average, around 46 typhoons pass the vicinity of Metro Manila. With climate change, rainfall brought about by typhoons and even monsoon rains have been more intense, more frequent, and even longer. This results to excessive volume of rainwater, which are existing water bodies, drainage and flood control system could hardly accommodate, thereby causing rainwater runoffs or flooding. Flooding has always been a perennial problem in Metro Manila, especially in the low-lying areas of the metropolis. Thus, an effective flood control operation system, more commonly known as EFCOS, was designed to complement the operation of our two major control structures to address flood management along the Pasig-Marikina River and the Laguna Lake Complex. The Mangahan Floodway Channel diverts excess flood water flowing into the Marikina River towards the Laguna Lake for temporary storage to limit floodwater in the lower Marikina River to backflow capacity. The channel also allows reverse flow from the lake to the river. The Napindan Hydraulics Control Structure, on the other hand, was built to improve the water quality entering the Laguna Lake by preventing the backflow of saline and polluted water from the Pasig River, especially so that the lake is being utilized for aquatic resources and to some extent for agricultural purpose. The catchment area of the EFCOS project is divided into two. The Upper Marikina catchment with a total area of 529.5 square kilometers and the Lower Marikina catchment with a total area of 91.5 square kilometers. The catchment areas are parts of the Pasig-Marikina River Basin, which is one of the 18 major river basins in the Philippines. The EFCOS project system monitors the rainfall activity within the project area. The gauging stations collect the real-time hydrological data transmitted to the Rosario Master Control Station. The flood information are visualized and the output are shared and transmitted to the concerned agencies and other flood control facilities. In the 2002 rehabilitation, the data are transmitted by a simplex radio system using emergency radio and telephone communication. Once the Rosario Master Control Station has the real-time flood information, the decision to issue flood warning within the basin is given to the hydrologist, who makes the command to conduct gate operation based on set protocols in order to divert water flow through Mangahan Floodway to minimize flood damage. The EFCOS Project Phase 1 was started in 1985 and completed in 1993 through a loan package under the Overseas Economic Cooperation Fund, or OECF, amounting to 254 million pesos. The system, which uses analog telemetry, is for monitoring and is not capable of flood forecasting. There were two rainfall gauging stations, which measures the amount and intensity of precipitation and determines its beginning and ending time. One in Mount Oro, located in San Isidro, Montalban, and another one in Boso Boso, located in Antipolo. Complementing these two rainfall gauging stations are 9 water level gauging stations located along the Pasig-Marikina River, which record the height of water surface in the stream. They are the Montalban, Santo Niño, Rosario Junction Side, Rosario Lakeside, Angono, Napindan Junction Side, Napindan Lakeside, Pandacan and Fort Santiago, which are capable to transmit real-time flood information in an hourly basis. In addition, the system has 9 warning posts, 8 of which are located on the east and west main dikes of the Mangahan Floodway Channel, while 1 is located inside the Rosario Master Control Station. The warning posts are equipped with sirens to alert and warn residents living along the floodway to stay away from the channel before the floodgates are opened and floodwater diverted, and to find safer ground to save their lives and properties. These warning posts are controlled and connected to the Rosario Master Control Station through cable and very high frequency radio. There are 4 levels of warning system. Level 1 is the precaution stage. all gates are closed, and voice broadcast warning 1 is issued. Level 2 is the caution stage. Voice broadcast. Warning number 2 is issued within 30 minutes after the observation of the critical water level at Santo Niño Water Level Gauging Station. Level 3 is the emergency stage. Voice broadcast warning number 3 is issued. Based on the judgment of the hydrologist in Rosario Master Control Station, as floodway is expected to rise due to large volume of water coming from upstream of Marikina River. Level 4 is a post-flood stage. Voice broadcast warning number 4 is issued as the water in the floodway is decreasing, but a caution is given to the people because of the possible occurrence of flood.
A discharge warning from the Rosario Master Control Station. The release of floodwater shall now commence through the Rosario floodgates. The level of water will soon rise and its flow will gradually become swift. The public is advised not to go near the floodway channel for your safety. Ito ay batala mula sa Rosario Master Control Station. Sinimulan na ang pagpapalabas ng tubig baha sa tubig lagusan ng Rosario. Inaasahan ang malakas na pagdaloy ng tubig at pagtaas ng sukat nito. Pinapayuhan ang lahat na lumigas mula sa tubig lagusan upang maiwasan ang anumang sakuna. Maraming salamat po.
Lastly, relay and monitoring stations were also constructed in Antipolo, Pag-asa Science Garden, and Rosario Master Control Station, which will enable to share vital flood data in an hourly basis to other key agencies handling flood information data. Realizing the limitations of EFCOS Project Phase 1, Project Phase 2 involving systems upgrades were done in 2001 through the Japanese government grant facility amounting to 411 million pesos through the Department of Public Works and Highways. This included the installation of additional hydrological observation stations, deployment of emergency radio communication in the pumping stations and concerned local government units, the introduction of digitized telemetry system, and the introduction of flood forecasting system. Specifically, additional 5 rainfall gauging stations were constructed located in Mount Campana, Mount Aries, Nangka, Napindan, and Science Garden, while 2 more water level gauging stations were placed in Nangka and San Juan. However, through the years starting 2006, equipment failures and malfunctions due to wear and tear, as well as usual depreciation, were experienced. Worse, the system experienced data absence, particularly in the downstream area, after the occurrence of extreme weather events such as Typhoon Ondoy and Neneng, wherein vital stations were severely damaged. Lightning even damaged the microwave and multiplex communication in Antipolo Relay Station. Shown in the diagram was the status of the EFCOS telemetry and warning system before the rehabilitation. EFCOS functionality then has dropped for about 40% due to multiplex system failure in the Antipolo Relay and Monitoring Station, which is the sole backbone of the system. Despite interests from funding agencies to rehabilitate EFCOS, it was only in 2013 that MMDA submitted the EFCOS Project Phase 3 rehabilitation proposal to the government of Japan, which was approved for funding in 2014 under the Technical Cooperation Program of the Japan International Cooperation Agency. The rehabilitation, which ran for 18 months and completed last February 19, 2016, focused on the immediate restoration of the damaged EFCOS equipment caused by extreme weather events. For the first time, the NMDA was able to secure a National Telecommunications Commission radio station license, which will operate under the 150 MHz assigned frequency. The Rosario Master Control Station houses the brain of the system. It is composed composed of telecommunication, telemetry and warning equipment, as well as an advanced computer system with flood forecasting capability. The rainfall gauging station houses the tipping bucket that measures the intensity of precipitation or rainfall. This device is connected to the telemetry and transmitted to Rosario Master Control Station via very high radio frequency. The water level gauging station houses the water level device that can predict the rise and fall of the level of water at a specific river. EFCOS has two types of water level sensors, the pressure sensor and the flow type sensor, which are both connected to a telemetry system and transmitted in real time to Rosario through very high radio frequency. The Antipolo and Pag-asa relay stations served as relay points for the multiplex communication system of the EFCOS project. The warning system alerts and warns residents along the floodway before, during, and after the opening of the floodgates. LCD panel display were installed in all warning posts, except in warning post numbers 4 and 8, wherein a new warning equipment was installed because the old warning equipment was fully submerged in water. Also part of the rehabilitation works is the replacement of new microwave antenna, which uses very high radio frequency under 150 MHz assigned by the MTC. IP radios were also installed in relay and monitoring stations, while VHF radio were installed in gauging stations and warning stations. The DMP equipment and the rest were installed in rainfall and water level gauging stations. Monitoring stations were also improved with the installation of telemetry equipment, computer system, printer, and a display panel to share the EFCOS data to other agencies who handle flood-related issues in Metro Manila. To ensure open communication among the monitoring stations, the system also installed a voice-over IP, which can be used especially during operations. The flood forecasting component of the EFCOS project complements the synchronized operation of the Rosario Weir floodgates and the Napindan hydraulics control structure. Currently, the forecasting tool can be used for the gate operations of the Rosario Weir. The table as shown is a sample recording output, which presents the propagation and the time travel of floodwater going downstream. It also included the water level status, such as alert, alarm, and critical level in the water level gauging stations along the Pasig Marikina Laguna Lake Complex. The gate operation rule curve, on the other hand, serves as a guide for the hydrologists to ensure proper gate operation and discharge of floodwater towards the Laguna Lake. The gates are randomly opened based on the amount of rainfall intensity observed within the catchment area. In 2012, the gate operation rule curve was revised because the river bathymetry was changed and a lot of constrictions were observed. The opening and closing of floodgates at the Rosario Weir will be based on the observed water elevation at the control point, which is the Santo Niño water level gauging station. With the completion of the restoration works of the telemetry system and replacement of radio system working under 150 MHz NTC assigned frequency, among others, the improved EFCOS is now capable of utilizing rainfall and water level data better and more efficiently. This will no doubt help Metro Manila become more prepared, thereby minimizing flood damage, saving more lives, and safeguarding properties with the end in view of protecting the economy in general to pursue growth and development in the greater Metro Manila area. Let us work together in promoting a flood-resilient metropolis. The MMDA, your partner in progress.